talk about modularity and how to use it to reach the software excellence. And from Luca to Luca, please give a huge round of applause to Luca Mezzalira.
Thank you. Good morning, everyone, and welcome also from me at Codemotion. So, you know, this for me is a very special year. This year marks 2 decades in the tech industry, and as usual, when you reach like a big milestone, I tend to think and analyze what I can do better, what I screwed up, and what I've learned during the journey, and I have tons of data points after 20 years, to be honest with you. And if I think about that, overall, I think I was very lucky. I was able to work on mobile embedded systems where you need to optimize every kilobyte in order to make your software working. And I work in designing on a global platform in the cloud where I had to onboard millions of customers and users in less than 60 seconds. So I've seen a lot, and I learned a lot. But one thing that during this year I was thinking, what is the key takeaway for me, is that there is a link, a connection between writing code on mobile to designing distributed system at scale. And this connection for me is called modularity. And during these 40 minutes, I will try to convince you that first, we need to focus more on modularity, because it will enable us to reach way more and design better software for tomorrow. See if I'm lucky and it works, and it doesn't. But as a pro speaker, I have always a fallback. Let's see if it works, this one. Yes, it works. Okay, so let's start with what is modularity, right? Modularity is the quality of consisting of separate parts that, when combined, create a complete whole. But a system lacks on modularity when a tweak of one of its components affects the functioning of others. Sounds familiar? Anyone? I think if you have written some lines of code, probably you know what I'm talking about. And bear in mind, the source is nothing related to tech. This is the Cambridge Dictionary, so it's applicable to any single field in our life. So why do we need modularity? Why company needs modularity? Very often, you know, we think that at the end of the day, the scope of a company is be lucrative, making money, right? And, you know, there is nothing wrong with that if you're done responsibly. But what does translate for us on the tech side? But first and foremost, when companies want to make money, it means that they need to react quickly, and therefore they need agility. They need the way to drift towards a different direction. Think about like the pandemic. A lot of companies has to drastically change in a matter of weeks, if not days, the way how they were operating, the way how they were doing their job. And it wasn't easy. And without modularity, we cannot achieve that. But also it means, for us, techies, that we want to reach the fast flow, or better, a flow that enables us to have a constant feedback loop. We will see later why. So this is me at the beginning of my career. So after 6 months on a project, I was talking with my colleagues and with my manager. Oh, sorry, this is spaghetti code. But we cannot go ahead. We need to start again because there is too much overhead. It's complicated. I cannot add a new feature, and so on. But then, when I started to think that 20 years later, I have more different ideas of this thing. And I start to recognize friction. And I'm extremely thankful to friction, because friction is a feedback that is provided by the system, architecture, code, teams, wherever you want, in order to tell us that there is something that is not right. So when I think about the different dimensions that compose a system as a whole, you know, where we define modularity, I think about the architecture, I think about the organization, and I think about culture. Now, you might think, oh yeah, but these are not connected. I'm a developer. How can I influence the other two? Wrong. You are wrong for a simple reason, and I give you a quick example. Think about the decision to go from polyrepo to monorepo, or vice versa, up to you. So this seems like a technical decision, right? So I'm just deciding how I want to store my code, how I want to do, let's say, the build and CI/CD, etc. Wrong, because you are defining how your teams are communicating with each other. You are defining that certain engineering practices has to be available in the trenches. You are defining way more than a simple, oh, I choose monorepo. And therefore, today we are going to cover this, and we're going to focus at the beginning in architecture and organization, because every time that you touch one of these dimensions, accidentally or intentionally, you're going to affect the others, that you like it or not. Therefore, it's not an if, it's when. So in modern architecture, there is no one solution that fits them all, okay? I remember in the old days, you said, oh yes, this is a design pattern, or this is MVC. You cannot go wrong with that. Not anymore, because we realize that we have to take into account multiple dimensions. It's not anymore code. And therefore, we live in the realm of trade-offs. So every time that we take a decision, we need to make sure that we analyzed our trade-offs in different dimensions. And as let's say, my heroes in architecture, Neil Ford and Mark Richards, says, it doesn't mean that in your case there isn't any trade-off. It means that you didn't find it yet. And they continue saying also, bear in mind that you need to find the least worst solution for your problem, because there is always a trade-off. So how modularity manifests inside the system? This is the question I was thinking. So when I start to research, I think that there are two ways, apart from architecture, that is infrastructure. I could potentially say, moving from back in the days, racks and virtual machine, and now we're moving to containers, into function as a service, and so on. So we started to create smaller pieces that all together create a system. Or you can express in code, right? So all the design pattern we learned, strong encapsulation, whatever other pattern you have in your mind right now. And you can combine both, by the way. It's not that are mutually exclusive. So if you think about a monolith, for instance, a modularity expressed in code means that I can use design patterns. Okay, that sounds good. I can use shared libraries. I can abstract a layer of complexity and make it available for everyone. I can even go further. I can say I can define my packages, classes, methods, depends from the language, but anyway, this is where you can go. And the end goal overall is having a cohesive code base. Because when I was working in several teams that were working on the same code base, you are extremely careful to introduce new techniques, because otherwise someone else that will need to pick your code maybe doesn't know about that. But also you think about there is less operational options. So I need a container, virtual machine, whatever it is. I shove my code there every time, and it will be done, right? So easy peasy. I will have a slower feedback loop in the long run, because in my experience, after 6 months, as I said before, you might risk that your code is not well maintained, is not well designed, and therefore is not ergonomic for developers, it's not easy to pick it up. You will have, at the end, higher cognitive load, because what happens and probably some of you or many of you have experienced the same thing that I did. What happens when you have like a large code base that you need to maintain for multiple years? That you became the master of all trades. You know about the catalog, the checkout, the payments, and any kind of domain inside the system. That therefore, it makes you, let's say, understanding the entire thing, but you are not mastering anything. If I think about onboarding, because back in the days, I have also to think about that in one or couple of roles that I did in my career, you will have a longer onboarding. Because if I join a company that never seen the code base before, I need to start to understand the code base, understand their patterns. Luckily, the documentation will be, well, let's say, up to date and everything, so I can start to contribute. But that requires a month, usually. And last but not least, because you want a cohesive code base, you need to be disciplined as developer. You cannot go rogue and say, oh, yes, now I'm going to implement this thing and use maybe a different framework. Obviously, experience tells us that not all workloads should be treated equally, right? And therefore, at some point, we started to evolve our architecture and start to think about something different, like applying modularity at the infrastructure and code level. So when I think about that and distributed system in general, so microservices, whatever, I think about decentralization. And you might think now, oh, decentralization, perfect, so I take like my system and I split it up. Yes, but it's not the decentralization that I care about. It's the let's say the organization decentralization. The fact that developers and teams must have skin on the game, because if they don't, then we have a problem. You cannot use the power of distributed system if you don't have this capability. You can start to pick the right tool for the job. So you need to have a SQL database, perfect, so that microservice will have it. You need a graph database, same. You become domain expert, amazing. So finally, you're not mastering the entire code base. You have like a very narrow scope, but you are mastering that. You maybe even help the product team to take the right decision. You lower the cognitive load, great, because I'm just thinking about my part. I don't have to think on the whole, and maybe in a year time, I will have, let's say, more interaction with other teams for handling that. But also, distributed systems mean that there are more team responsibilities, the shift-left movement. And now developers are not just writing code and throwing on the other side of the fence. You start to think about, oh, I need also to think about the CI/CD. I need to think about the observability dashboard. I need to think about the load testing and so on and so forth. There is clear ownership. You own, so you build it, you run it. Amazon was saying many companies embrace that, and that is history. There is more complexity because now you need to, instead of knowing everything about a specific language and all the patterns and a code base, there is more complexity because you need to have a variety of skills. It's not anymore just I write code. You need to have intentional governance. Very important here. I have seen too often companies that are claiming that the distributed system doesn't work, because there is friction. The friction is just telling you that you need to create some mechanism. So let's try to see how in this reusability characteristic or architecture characteristic you could apply modularity. So let's assume that you have, like here, a share library in a monolith. So this share library starts to, let's say, be an abstraction, and I update and I create the abstraction, and in my monolith, I maybe have this library that is available for all my code. So I just, let's say, start to use it. Suddenly, a few months later, you need to change it because there is a breaking change. Now you need to coordinate across all the different parts where the API is called the change. So you need to change the name of the function, the method that and the parameters inside the method, whatever. Similar, also on distributed system. In distributed system, I have like a shared library, but there is a big advantage there. I have a shared library and I share multiple microservice. If I'm doing properly my job and I work with backward compatible API, I can, and maybe I defer the breaking change, I might arrive to a point where you really nail it. And I have, let's say, teams that are constantly updating at their own pace based on their capabilities. So now modularity is expressed in two different contexts, but you have different trade-offs that you have to think about. Now, before you start with the flame on social media, Luca said that distributed systems are better than monolith or vice versa. There is no right or wrong. We said in modern architecture there isn't such a thing. And therefore, you need to think about your context. How much do you know about your context? How you can take decisions? Because the reality is, when you are embracing an architecture, you say, I have heard like a bazillion of time, developers say, oh yeah, but in Spotify are doing that. Oh, but in Amazon are doing that. Oh, but in Netflix are doing that. Sorry, breaking news, that's not your company. And therefore, if you don't understand how you can apply the learnings behind a specific architecture or approach design pattern, then it might not work inside your company. And it's not a problem of the architecture. Big spoiler. The other thing is the modularity fosters another interesting thing, internal cohesion and low coupling. So I create modularity around a specific system or specific library, whatever it is. So in this case, for instance, let's assume that it's a microservice. I have my code that is represented by those bars, and I change a part of my code. The API will remain the same, and you are an happy camper because you have internal cohesion. You can change things in the way that you want. Moreover, you start to think about, okay, how can I, let's say, have low coupling, and you define, okay, I have two services that has to communicate together. Should I go point-to-point with the discovery service? Should I use an event-driven architecture with an event? What is the best way? And again, there isn't right or wrong. It depends from your context. Modularity also enables the right level of granularity that is different. When I'm thinking about the service, but also applicable to libraries, what you think about that is, okay, what is the ideal size for a service? How micro is a microservice? Have you ever asked yourself this question? I ask it basically every time. So the problem is there aren't great heuristics. I have seen people saying, oh, yeah, it's 100 lines of code. That's the microservice. So, great. And if I cannot, do you count those the libraries or not? And therefore, I started to think, okay, so let me research. And this is a research that I did in the past when I was designing this kind of system. So how would good looks like? So this is a very interesting heuristic that is coming from the 70s. So distributed system were like not even thought. So this one is a shallow module, okay? And the field rectangle with the light blue is basically your API contract, and inside you have a very shallow module that is the business logic for maybe doing a CRUD operation, like you are creating, writing, whatever. So this has a problem, because every time that I change the database schema, it means that I need to change the API contract, so breaking changes, so I need to coordinate with other teams. So ideally, what you're looking after is a deep module, an API contract that is smaller, more business logic, so more coarse grain than fine grain, and as John Osterhout, I hope that I pronounced correctly, suggested in the philosophy of software design, this is a good heuristic to start to think how micro is a microservice. If you find yourself changing every single week, every single time that you make a new feature, you need to change the API and change across the entire system, probably you are in a shallow mode. But let's go even deeper. It's very difficult to have black or white in a situation like that, right? So it's, sometimes things evolve, and something that was very well designed at the beginning is not anymore. Because the reality is software is a shades of gray, is not something that's absolute. And therefore, when I think about how micro is a microservice, I need to think about different dimensions. I need to think about code volatility. How often I change the code? Can I collocate that code in order to write once, and maybe that part will never change, or will change sporadically? Or maybe I want to have like an area of the system that changes very often, and therefore I need to, let's say, carve it out and put in a separate service, library, whatever it is. I need to think about scalability and throughput. Designing a service for 1 million requests per second is completely different than designing a service for 10 requests per second. So don't use the same tools. Fault tolerance. How can you, let's say, make your system resilient if a part of the system goes down? How would it behave? You need to think about that. Security. Obviously, security is extremely important, so we need to think also how we are going to handle the security inside our system, how two microservices are communicating together. Are you using HMAC? Are you using an API, a key? Are you using, I don't know, a JWT token, whatever? You think about extensibility is needed. Do you need extensibility or not? And therefore don't abstract, because it's way easier to write code that is not abstraction. I know as a former developer, abstraction is the coolest thing that you can do. I did that bazillion of times. But, let's say, if I think holistically, it might be not the right option. And what's the scope? How micro is my microservice is based also on what you put inside there, or how big is my shared library. So then we think about modularity in another dimension. So, for instance, in the architecture space, I'm a huge fan of architecture. And in architecture, if you read, let's say, the books from 80s, 90s, 70s, wherever, you talk about ilities, so the capabilities of your architectures, how you describe them. So I pick 3 just to give you an example, but the idea of modularity can be, let's say, assigned to multiple other ilities. Maintainability. I have this nice monolith, and every time that I need to change something, it takes me 2 months for a release. Maintainability is not, let's say, it's a problem here, right? So we need to think about that. But if I start to refactor, and I start to carve out multiple libraries, and I do my job properly, and maybe I create, let's say, a modular monolith where I have multiple, let's say, VM or containers, whatever, that are handling portion of my code, but then I can probably think to change a portion of my code and make it more maintainable. And if I change this part, I would not need to retest everything. That is, let's say, a good perk of embracing this approach. Scalability. So imagine that we have multiple services, and the service in the middle, the one with the arrow, start to have high requests. If I have to think that I collocate all the code wrongly, you might risk that you need to scale also for a specific API that doesn't have many requests. So it's a problem. But if I design properly and modularize properly my code and my service, I can start to do auto-scaling at that level and start to think, okay, great. So I can start to, let's say, scale that part. The rest maybe is behind a CDN, so highly cached, and therefore it doesn't receive many problems. But maybe this one is the personalization service that is personalized on a user-by-user base and requires to scale. There is nothing wrong, but in this case, makes the life easier. It's way easier to scale one service to 10,000 requests than having the whole application scaling to millions of requests because all the traffic is going to the same point. And then I think about portability. You know, I'm a serverless specialist, and very often I hear about, you know, and with Lambda functions in AWS, you might have lock-in. But, you know, as I said, I was a former developer, and what I learned in the past is that there are ways, there are design patterns that help you to reach portability. Imagine you have a hybrid implementation of your system, on-prem and on cloud. Think, for instance, what really matters for you. Classic example is the business logic, right? So it's the business logic that is very important. So if you are a way to decouple the business logic from the environment where it's running, then boom, we have the heat. And that turns out is called hexagonal architecture. And if you work with port and adapters, you basically isolate your business logic. All your unit tests are well written and was created back in the days in early 2000 and enables you to move from one part and another one, just changing the parts that are not common. Therefore, instead of using maybe a service in a cloud provider, you're using let's say, self-managed service for caching or a different database or stuff like that. Or maybe you use like a unique database for everything, so you don't even have to change your system. So as you can see, if I think about modularity, I can express it in so many ways that I can really help in designing my system. But also helps in resilience. Nowadays, I think is mandatory thinking about resilience because 90% of our time is spent on a web browser that have possibly all our details, bank details and bank movement, bank accounts, and you have everything about social and whatever. And therefore, we need to think about that. So fault tolerance, for instance, if I choose two parts of the system that doesn't work, how would I handle the system? Should I just, let's say, hide gracefully and it's not a problem? Should I return an error to the user? What's the point? So we need to think about this. But if you have modularity, then this discussion became extremely helpful and easy to handle. Another thing is iterative deployment. I'm a huge fan of it. And if you think about, in this case, this is the distributed system, I can easily say, oh, I want to deploy these two parts, but hang on. I don't want to deploy in a big bang fashion. I don't want to have 100% of the traffic there. I can start to say, dear developer, every time that you deploy, you use canary release or blue-green deployment. And that enables me to redirect a portion of the traffic towards the new version, test in production, and having for a small amount of user, let's say, the traffic to a new service, and that will enable to get, let's say, more insight than having a 100% rollout where maybe it causes more harm than anything. If you work at scale, you can even think about, I want to deploy this service in this region, and then later on in another region, and then on another region when I feel confident. So you create a safe net for developers to do that. But without modularity, you cannot, because if you have everything, all the eggs in the same basket, is a problem. I hope that by now you understand that modularity is basically everywhere, in every single decision. And if you don't think about that, we have a problem. So how can I design a modular system? Okay, so let's start from this. And you think that I'm joking, but I'm not. You have no idea how often I spoke with customers and I ask, listen, can you tell me your business requirements? Don't know. Can you tell me your SLAs? What is the latest that you want to have, what you want to achieve, so at least I can wire my head and help you out on that? I don't know. So if you don't have the business requirements and you don't have the architecture characteristics, what are you designing on? What are you writing code on? Honestly, it's a big problem because you are basically using your time for creating the best effort that I'm sure you're doing, but it's not a playground for developer. Here we are trying to create value for our users. And therefore, as Alberto says, what goes in production is the misunderstanding of the developers, not the product expertise. So if there is a bridge between these two teams, then we have a problem, because I don't know what you are writing, honestly, in production. So how can we think about that? But the solution for me in these 20 years of experience was communicate and visualize. The problem you see, I've seen very often is, okay, now I have multiple teams that are working on the same project. Monolith or distributed system doesn't matter. But we are not thinking intentionally on how these teams are collaborating together. Because, again, even in distributed system, we are not creating silos. We are reducing external dependency, reducing, not eliminating external dependencies. And therefore, that you like it or not, in wherever, let's say, chat message that you have in the company, you need to discuss with your peers how to evolve the platform. And even in modern architecture, where there is a tendency on decentralized architecture, that doesn't mean that fades away. It's still there. It's a shift, the priorities, right? And the ownership. And therefore, you need to discuss with other team on how to evolve the platform, like you were doing in a monolithic code base, because that's usually what you do. And you need to visualize that, because asynchronous communication is one of the most powerful ways to keep people in sync across multiple regions, countries, whatever. Think about requests for comments. If you think about architecture and decision record, all these way and mechanisms to create awareness inside the system are extremely important. So domain-driven design, you can do, let's say, a masterclass of weeks or months before you understand domain-driven design, and 1 year when you start to be a practitioner. But for me, the key point of domain-driven design is that facilitate communication. What they understood as a community is that unless we start to communicate effectively, there is no way that the system will be the one that we want. And therefore, you can apply modularity randomly, but it's not going to provide the right, output. So event storming, for instance, is a great solution. I'm doing event storming with a lot of customers. We're going there, we start to remove all the business, all the technical part, and we take the techies, the business, and we start to map it, what they want to achieve. You have no idea how often I said, oh, I didn't know that that is working that way. Or you expect that was working that way. And that was the developer was writing the code. So these are great techniques to start to think outside the box on that. Domain storytelling is similar, but it's another technique that enables you to map, first of all, the intention, what you want to achieve. Because without that, you cannot apply modularity. Wordly map is even more interesting because you can work at the C-suite level or in other different systems and understand what is pivotal for the company and what is not pivotal, and you can buy over build. But there is another thing that I really love about domain-driven design, because when I do event storming, I usually arrive to have like a clarity on the boundaries of the system. I can see from the vocabulary that I'm using when more or less there is a split. And domain-driven design helps you to categorize these domains and start to say, okay, you have a core domain, I give you an example. Core domain is critical for the business. Netflix. You go to Netflix because you want to watch at any given point in any device your favorite movie, or let's say whatever it is. But Netflix has also other capabilities, like supporting domain. If personalization is down, you don't care too much. I mean, yes, it's not ideal, but you can still watch your content, right? And also you have like some generic domains. Think about payment. You cannot access Netflix if you don't pay. But do you really think that Netflix is creating the new PayPal, or is just using PayPal? So as you can see, oh, sorry, it didn't go ahead. As you can see, when you identify the modules here at the high level, on the architecture level, of a specific system, you can assign characteristics. And when you assign characteristics, you have a different discussion with your peers, because now they know, oh, you are in a supporting domain, so let's discuss buy versus build. Is it needed? Is it not needed? Or stuff like that. Is it generic, therefore probably integration patterns you look at. And you have to think about, okay, how I can reduce the strain towards the CRM that cannot scale at the level of traffic that I have. But if it's core, you want to have a super fast feedback loop, because you are innovating there. It's the reason why the company exists. So that leads to, okay, we understood the architecture, we define the modularity on the architecture, we start to apply capabilities. But there is one book. If one book you read this next year, it will be Accelerate. Okay? Accelerate is a study across 2,000 companies in the world, and they identify the traits of the most high-performant companies. These are some of them. I didn't have more. But deployment frequency, lead time for change, time to restore a service, change failure rate, you know? And very often it's an afterthought. And it's a problem, this one, because if you don't have that, and then, you know, the feedback loop is broken, it's very slow. So we need to embrace an automation culture that we like or not. Unfortunately, nowadays, the competitive advantage is trying to get before our competitors with that feature, or being better on an existing feature. And if you don't have that, and you cannot tweak, and developers don't have the feedback loop, the right feedback loop, we start to have problems where developers start to cheat the system. Oh, it worked in my machine. Have you ever heard about that? Of bazillion of time. Amazing. The other thing that we really need is fast feedback loop. Now, when I say that, usually people think that I'm crazy. But you need to take your architecture characteristics, as many as you can, and move as close as possible to the developers. For instance, imagine you have a shared library, and everyone is using a Git, let's say, repo for version control. And you say, okay, we want to enforce that this specific library, that maybe is a payment library that contains all the abstraction for integrating with different payments, are updated in every single part of my system. If it's a distributed system, it's a non-trivial problem, because how can you do that? And there are different ways, but for instance, if you're using Dependabot, you can force an open APR overnight and update all different parts of the code needed in order that the day after, the people will wake up and have a PR there waiting for them to be reviewed and merged. So many of those architecture characteristics can be, let's say, implemented into this, let's say, fast feedback loop that you are trying to reach. Therefore, shift left is a mentality that you need to foster when you're thinking about that. So what can I take as close as possible to the developer workflow? The developer workflows is usually, I write some code, I open a PR, and that is the moment where you need to catch it. Because then the developer is fresh with that information inside their head, and therefore they can change quickly. If you discover a problem in production, there are, let's say, a lot of researches that shows the developer has to go back to that code, and it takes, I don't know, several order of magnitudes greater than catching the problem at the beginning when they're writing code. And therefore, as you have seen in all of this, there is tension, because I never said this is the solution. In the whole presentation, I always showed you trade-offs, only trade-offs, because that is what we need to deal with, uncertainty. And when you are thinking about your solution, you need to balance your decision, as I said before. You need to really start to think about what is the least worst solution that could work here. And another big spoiler of today, that can change in 6 months' time, in 1 year time, in 3 months' time, because the business is not, let's say, static. It's changing, it's evolving. That's what you want as a business owner, as a CTO, as a CEO, whatever it is, right? And therefore, if you create friction at the architecture level, then no one is happy. So you might think now, is that all? Is it really that simple? More or less. There are a few other dimensions we need to think about. So how many of you heard about the Conway's law? Few of you. So the idea is you design your system based on the structure of your teams and the communication structure inside your organization. Now, I did on purpose one thing. I added the year when this law was coined. For roughly 15 years, they ignore melding. They said, who cares? It's not the dimension we care about. Suddenly, from 80s, early 90s, but that guy was smart. He knew his stuff. Now it's like the slide that I have seen the most in every conference when you talk about architecture distributed system. Now, therefore, when we have architecture and organization we touch, we need also to think about culture, because unfortunately, you cannot have the perfect social technical system if you don't think about that. The social technical system is extremely important. So thinking about centralized organization. So if you have a centralized organization where you have a tech leadership that is deciding everything for you, you're just writing code. The teams are growing organically. You don't know if they are communicating properly. There is friction, there isn't friction, stuff like that. That's the problem. Because then you cannot expect to have fast feedback loop. You cannot expect to have certain traits that I described before. If you have a decentralized organization, it's slightly more complicated, but team topologies helps. And the guy that created team topologies will be here tomorrow. So you can have some value stream teams that are people that are focusing on generating value for the user or for your customers. You can have complicated subsystem teams that are enabling others to fulfill other requirements without thinking too much about that, like the data team. So if I need to understand how the click stream for creating if I want to create a personalization service with an ML model that is owned by the data team, I can easily send from any value stream this information in a landing zone that then will be picked up and analyzed and so on. So this is like complicated subsystem team. The developers don't have to know about that. You need to have a platform team that is creating the platform, but, and this is a big but, so you need also about enablement teams. And the one that I want to have your attention on is the developer experience. Because very often, we do the platform team, we do the value stream teams, we have the security as an enablement team, but then, sorry, the platform team doesn't speak with developers. How does it work? So we need to remember that we don't operate in a scientific world. And therefore, what you think that is, let's say, replicable, maybe it's not. We exist in an empirical one. So trial and errors, anyone. So we need to use a process that enables us to have short feedback loop, analyze what the plan was after doing that, and revisit our decision. If you try it today, and you provide the same specs for a project to two different teams, without telling them the technology to use wherever, I can guarantee you that they get close, but they are not going to produce exactly the same thing, because it's not scientific. So friction for me, going back to the initial statement, is a gift. It's not a problem. Because every time that there is friction, it means that something in your process, in your culture, in your organizational structure, or in your architecture has created that. And maybe evolved based on some business requirements. But still, it's not the problem of the system. So again, analyze and visualize. This definitely helps. And this is something that I always say. Stop blaming the architecture. I heard so many times, oh yeah, this team moved away from microservices back to monolith, or this team moved from monolith to microservices, and therefore monolith doesn't work, or microservice doesn't work. No, it's not the case. You don't get the point. The point is, they moved away for certain reason that they are never telling you or they forget to tell you in a talk. They don't describe the context. If you don't understand the context, you cannot judge if it's the right or wrong. Because what we want to reach overall with modularity is evolutionary architectures. We want to have all the characteristics to change a portion of the system without any problem. To wrap up, do you know what I understood? So first of all, that modularity really helps, especially intentional modularity, the one that you intentionally think, okay, how can I handle this specific problem? But more importantly, there is no failures, but just learnings. I grew up in this country. I lived here for 30 years. I moved away, but one thing that I remember is that here and in many other countries around the world, failure is a problem. Failure means that you don't count, you are a disappointment. But surprise, third spoiler of the day, it's just learnings. It's just the path that you need to follow in order to achieve what you want to achieve. And therefore, I want to leave you with one thing and one thing only. If there is one thing that you need to take from this keynote, is this one. Remember that you need to grow your software, not build your software. Because build is an action that is, you build and forget about that. But if you grow, you are treating your software as it deserves, as an organic entity that can change, mutate, and they have to take care of it. Because otherwise, it's not going to work. Thank you very much.